To do the actual saving of the user, we want to call the specific core API platform data persister that normally saves entities. So, how can we do that? To start, we need to figure out which service is responsible for that. Let's do some digging. Run bin console debug container and search for API platform. This shows all of these services from API platform, which is a bunch. Search for Doctrine. Okay, a metadata factory and API platform Doctrine ORM data persister. I'm pretty sure that's what we want. I'll enter the number next to it, 105, to get more details. Okay, the class is called just data persister. Back in PHP Storm, hit Shift, search for data persister, and make sure to include non-project items. Select the one from API Platform's Doctrine Bridge. And cool! This looks pretty much exactly like we expected. It persists and flushes. This is what we want to inject into our data persister. Let's do it. Back at the terminal, copy the service ID. Instead of relying on auto-wiring, we can explicitly configure this argument on user data persister. To do that, open config/services.yaml, head to the bottom, and override the service declaration for app/data/persister/user data persister. Beneath, add bind, and then the argument name, which is decorated data persister. So $decorated data persister set to an @ symbol and then the service ID. Thanks to this, Symfony knows to inject this specific service instead of the normal chain data persister. To prove it, try the tests again. Symfony run bin/phpunit --filter equals test create user. And got it. What we just did got pretty deep into API platform, Symfony, and services. But this is the kind of stuff that we're going to be doing in this tutorial. And I want to point out a subtle difference between what we just did and how we hooked into a different part of API platform in the last tutorial, specifically the context builder system. In both cases, we wanted to run custom code inside part of API platform. For admin group's context builder, we used a decorates option. But in this case, we didn't. Why? Let's talk about how the context builder system works in Symfony's service container. Open up our custom class, app serializer admin groups context builder. The class itself is pretty simple. It implements serializer context builder interface and adds some conditional serialization groups based on the current user. We also inject a decorated object that has the same serializer context builder interface. So on a high level, this is class decoration. We are decorating some other serializer context builder, calling it, but also adding our own logic. In user data persister, we are also doing class decoration in the exact same way. But the way we get this working in Symfony's service config is different. Why? Because the way these systems work in API platform is different, requiring two distinct solutions. Check this out. Run bin console debug container context. One of the results is a service called API Platform Serializer Context Builder. This is the one context builder service in API Platform. Or, to say that differently, when API Platform needs to build the context at the beginning of the request, it calls this one service to do that job. Copy the service ID and rerun debug container with that ID and --show -arguments. Perfect. Notice the name, Serializer Filter Context Builder. I don't know what that is, but it does not sound like a chain context builder. And check out that third argument. It's passed our admin group's context builder service. Here's what's going on. Inside API Platform, there is only one context builder service. But unlike the data persister system, this one context builder is not a chain class that calls many other context builders. Nope, there is simply just one context builder service, and that's it. That creates a problem. If we want to add logic to the context builder service, the only way we can do that is by replacing the core service entirely. That is the job of Symfony's service decoration, and API Platform relies on it in several different places. Yep, the decorates option basically says this: I want to replace the core context builder service. I literally want to become the service that you get when someone asks for the API Platform.serializer.context builder service. But I also want that original context builder object to be passed to me as an argument. What you ultimately get is a bit like a Matryoshka doll, where you have one context builder service with another inside and another inside it. In this case, the outer context builder is apparently a serializer filter context builder, but then it does its work and calls our admin groups context builder. And if you run this same debug container command on our service, you'll see that our service is passed another one with the same name but .inner. If you debug that, its class is serializer context builder. This is the true original context builder service. It's been decorated twice, once by us and once by API Platform itself, to add more features. The point is, by leveraging service decoration, we can create a sort of chain of context builders, even though there isn't technically a chain class. But for the data persister system, this simply isn't necessary. That system has a chain data persister, and we can freely add however many data persisters we want simply by creating a class that implements data persister interface. Well, technically, we need to create a service and tag it with API Platform.dataPersister, but that happens automatically thanks to auto configuration. The point is, thanks to how the data persister system is built in API Platform, we didn't need to replace the core data persister. We could just add ours to the chain. If we want to call one of the other data persisters, we can inject it. But it's not service decoration. We're not replacing that service. To me, the data persister system is a better design. It makes life a lot simpler. Service decoration is a bit more confusing, but it is a valid option when it's the only option, like in the case of context builders. That is why you see two different solutions to hooking into a core part of API Platform. Next, the superpower of a custom data persister is the ability to do something before or after an entity is saved. But what if the code we need to run should only be called when an object is created or updated, or only for a specific operation? Let's find out how we can do that.